Hi, I'm recording a series of short videos about the Collatz conjecture, the 3x plus 1 problem. In this one I'm going to talk about powers of 2. And the context for my discussion is that the even numbers are actually not required to solve the conjecture, even though powers of 2 are considered to be extremely important to Collatz sequences, and they are if you consider even numbers to be important to sequences. So what we mean by powers of 2 are numbers that only have prime factors of 2. And for example, 16, 2 times 2 times 2 times 2. So in the Collatz conjecture you have even numbers, and so 16 becomes 8, becomes 4, becomes 2, becomes 1. And this is in fact the pattern that most, if not all, sequences end in. How do you get to 16? You get there from 5, an odd number, you multiply by 3 and you add 1. So a sequence of even numbers that contains powers of 2, as far as I'm concerned, might as well not exist. And they're actually a distraction to the solution of the conjecture. So let me give you a big example. 87,381. And I'm going to multiply by 3 and add 1, which gives me 262144. And then we there have a power of 2, factors of 2 only, and we can divide it by 2, halve it until we get to 1. It collapses. So division by 2, fine, if you insist. But it's completely unnecessary. Numbers that only have prime factors of 2 can basically be ignored, because we know our shoot is always going to end in 1. And reminds me of a well-known children's game, Chutes and Ladders or Snakes and Ladders. In other words, it's kind of childish. Multiplying by 3, adding 1, and dividing by 2. So let me ask you this: is 262144 the significant number, or is it 87,381? This is an important question. Why should we ignore the odd number we have before multiplying by 3 and adding 1? So why don't I come right out and say it? It's 87,381. That's the significant number, and it's not necessary to apply 3n plus 1. Or division by 2. So where did our 3x plus 1 problem just go? It went down the tubes. In this case, where we have a power of 2, we can divide directly before we get to the power of 2, before we multiply by 3, before we add 1, we can divide the odd number by 4 with the minor detail of subtracting 1 to make it even. So starting again with 87,381, we can subtract 1 and divide it by 4, and we get 21845. Subtract 1 from that, divide by 4, and get 5461, and so on. A sequence of odd numbers that ends in 5 and 1. So the odd-only sequence will actually always end the way the even one does. It just gets there in a completely different way. It's actually a proper subset of the even numbers, because the even and odd numbers, because the even and odd sequence also has 5 and 1. So each odd number in this sequence is the product of m minus 1 multiplied by a quarter, and this turns out to be one of 3 operations that produce every Collatz sequence, and with odd numbers only. So this is of some significance. Thank you.